Hello, this is and I'm going to go over the 4.3 right triangle trig classwork from part 1, section 1. What we're going to do in number 3 is we are going to find the exact values of the 6 trigonomic functions of the angle theta shown in the figure. Use this Pythagorean theorem to find the third side. So the first thing I'm going to do is, since I'm missing this side here, which would be the hypotenuse, or r, my base of my unit circle, I'm going to do 15 squared plus 8 squared is equal to r squared. When I do 15 squared plus 8 squared, I get 289 is equal to r squared. Take the square root of both sides, and I get r that equals 17. So this radius is 17. Now I can use my trig identities to find the 6 trig functions. So the sine of theta is going to be the opposite. So remember, I'm looking from this angle here. The opposite will be 8 over the hypotenuse, which will be 17. Its reciprocal cosecant is going to be the reciprocal of 8/17, which will be 17 over 8. The cosine is going to be the adjacent to this angle. So remember, the adjacent is the one that it shares sides with that is not the hypotenuse. So this is 15 over 17. And the reciprocal of cosine is secant. And the reciprocal of 15/17 is 17/15. And the last two, I'm going to do tangent. The tangent, remember, is opposite over adjacent. So opposite is 8, the adjacent is 15. So the tangent is going to be 8/15. And the tangent's reciprocal cotangent is going to be the reciprocal of 8/15, which is 15/8. And that's how I do right triangle trig. Okay, the next one, it says find the exact values of the 6 trigonomic functions of the angle theta for each of the triangles. Explain why the function values are the same. So what I'm going to do is I am going to have, I'm missing this side here. I have the hypotenuse, which is 3. So I'm going to say 1 squared plus x squared is equal to 3 squared. So then this will be 1 plus x squared is equal to 9. Subtract 1 from both sides, I get x squared is equal to 8. Taking the square root of both sides, square root, x is equal to, remember, I can think of 8 as the square root of 4 times the square root of 2. So x is equal to 2 times the square root of 2. So I'm going to write that in here. Now it wants the 6 trig functions, so I'm going to go ahead and do that. I'm going to always start with sine. So I'm going to do the sine of theta is going to be the opposite. Remember, opposite is a 1 over the hypotenuse, which is 3. The cosecant of theta is going to be the reciprocal of 1 over 3, which is just 3. The cosine of theta is going to be the adjacent, which we just found to be 2 times the square root of 2. That's all over 3. The reciprocal secant is going to start off as 3 over 2 times the square root of 2. To rationalize the denominator, I multiply by whatever's underneath the radical sign. So in this case, it's the square root of 2. I'm multiplying by the square root of 2 over the square root of 2. So when I multiply 3 times the square root of 2, I'm just going to write it as 3 times the square root of 2. So here I'm going to have 2, and the square root of 2 times the square root of 2 is 2. So this denominator is going to be 4. So my secant is 3 times the square root of 2 over 4. To find the tangent, I am going to do the opposite, which in this case is 1 over the adjacent, which is 2 times the square root of 2. Before I flip it, I'm going to go ahead and do the cotangent, because the cotangent is going to be the reciprocal of this, and I'm just going to take the reciprocal. So that's going to be 2 times the square root of 2. So that's my cotangent. But now I have to rationalize this. So to rationalize this, I'm going to multiply by whatever's underneath the radical sign. So the square root of 2, square root of 2. And I'm going to end up with the square root of 2 over, again, 2. That's that 2 there. And then square root of 2 times the square root of 2 is 2, 4. So the tangent is going to be the square root of 2 over 4. And it wants me to compare it to the other triangle. So let me go grab that other triangle. So the other triangle they gave me is the adjacent, no, the opposite side is 2, and the hypotenuse is 6. And if I'm looking at this, I should realize that if I take this triangle over here and I multiply this by 2 and I multiply this by 2, I am going to get the 6 and the 2. But let's just see if that all works out. So the first thing I'm going to do is I am going to find my missing side here, which I'm going to call x. So I'm going to have 2 squared plus x squared is equal to 6 squared. So this will be 4 plus x squared is equal to 36. X squared is equal to 32. When I take the square root, square root, square root, I'm going to think of x, and this is going to be the square root of 16 times the square root of 2, and I end up with 4 times the square root of 2. So this missing side is going to be 4 times the square root of 2. To do the 6 trig functions, I'm going to bring this down here so I have some room. So here's my triangle that I just have. And I am going to write this, which we just said was 4 times the square root of 2. Now I'm basing this off of that triangle. The sine of theta is going to equal the opposite, which is 2, over the hypotenuse, which is 6, and that simplifies to 1/3. The cosecant, which is the reciprocal of sine, is just going to be that reciprocal, which is 3. The cosine of theta is going to be the adjacent, which is 4 times the square root of 2, over the hypotenuse, which is 6. I can see here that I can simplify the 4 and the 6, and I end up with 2 times the square root of 2 over 3. The reciprocal will be the secant, which will start off as 3 over 2 times the square root of 2. Remember, I have to rationalize that denominator, so I'm going to multiply by the square root of 2 over the square root of 2. And I start off with 3 times the square root of 2 over 4. Again, that's 2, and this 2 times 2 is 2. Square root of 2 times the square root of 2. Then I'm going to do the tangent, which is the opposite, which is 2, over the adjacent, which is 4 times the square root of 2. Before I start rationalizing the denominator, I'm going to want to simplify and make this 1 over 2 times the square root of 2. And now I'm going to rationalize square root of 2, square root of 2, and I end up with the square root of 2 all over 4. And then doing the reciprocal is going to be cotangent. So cotangent of theta is going to equal the reciprocal. And I'm going to do the reciprocal from here, if you don't mind. And I'm going to have 2 times the square root of 2 over 1. And what you should notice is all these 6 trig functions that I just found match to this original 6 trig functions that I have. And that's because the sine is a ratio, and it's going to be consistent. As long as that triangle is a similar triangle, then the ratios will still be similar. And that's what makes sine and cosine and all these ratios so important, is if this triangle can have an opposite side of 2, it can have an opposite side of 20. As long as this is proportional and this hypotenuse is 60, then I will still have the same sine, cosine, because those are all ratios. Okay, looking at the next one, it says sketch a right triangle corresponding to the trigonometric function of the acute angle. Use the Pythagorean theorem to determine the third side of the triangle, then find the other 5 trig functions. So when I look at this, I have the sine of theta is equal to 5, 6. So I'm going to draw a triangle. And since it doesn't tell me, I'm going to pretend like all these triangles are in the first quadrant. So I'm going to get used to that pattern. And this is going to be theta. And the sine is the opposite, which is, I'm going to make 5, over the hypotenuse, which is 6, because I have 5, 6. So I'm going to think of this as the opposite side. This is the hypotenuse. Then I need to find this missing side here, which I'm just going to call x. And in order to do that, I am going to use the Pythagorean theorem. So I am going to start with 5 squared plus x squared is equal to 36 squared. So I'm going to have 25 plus x squared is equal, whoopsie, I went ahead of myself. This is 6 squared, which is 36. Subtract 25 from both sides, and I have x squared is equal to 11. So x is equal to the square root of 11. That does not simplify because 11 is a prime number. Then to find the 6 trig functions, so this is the square root of 11. To find the 6 trig functions, I'm going to say the sine of theta, which is what they already gave me, but I like writing it down again. The cosecant of theta is going to be the reciprocal, which is 6/5. The cosine of theta is going to be the adjacent, which we just said was the square root of 11, over the hypotenuse, which is 6. The secant is going to be the reciprocal of that, so the reciprocal would be 6 over the square root of 11. And then I have to rationalize that denominator. So I'm going to multiply by the square root of 11 over the square root of 11, and I end up with 6 times the square root of 11 all over 11. The tangent is going to be the opposite, which is 5, over the adjacent, which is the square root of 11. Before I rationalize this, I'm going to go over here and do the cotangent, which is the reciprocal of this. So I'm going to flip that over and make it the square root of 11 all over 5. Now I'm going to go back here and rationalize this denominator, and I'm going to do the square root of 11 over the square root of 11, and I end up with 5 times the square root of 11 all over 11. So those are my 6 trig functions. That was based off the sine being 5/6. Number 12, the cosine is 3/7. So again, I'm going to draw my triangle. Remember, cosine means adjacent over hypotenuse. So this is my right angle, which means the 7 will go here. Here's the angle I'm looking from, and then 3 will go here. I need to find my missing side here, which I'm going to call y. So I'm going to have 3 squared plus y squared is equal to 7 squared. So I'm going to have 9 plus y squared is equal to 49. Y squared is equal to 40. I'm going to take the square root, square root. Square root, square root. When I do that, I'm going to have y is equal to the square root of 40. I'm going to think of that as the square root of 4 times the square root of 10. So y is going to equal 2 times the square root of 10. And then you did that in Algebra 2, so I'm sure you just need a refresher and you'll remember how to do that. So let's go up here and do so this is 2 times the square root of 10. So now to do my 6 trig functions, I'm going to start off with the sine of theta is equal to opposite, which we just found was 2 times the square root of 10 over the hypotenuse, which is 7. The reciprocal of sine is the cosecant, so I'm going to take the reciprocal and make this 7 over 2 times the square root of 10. To rationalize the denominator, remember I'm only multiplying by whatever's underneath the radical sign. So square root of 10, square root of 10, and I end up with 7 times the square root of 10, and then 2 in the square root of 10 times the square root of 10 is 10. So I end up with a denominator of 20. To find the cosine, I'm going to take the adjacent, which is 3 over the hypotenuse, which is 7. And they gave me that, so that's good that it matches. And then the secant of theta is going to be the reciprocal of this, which is 7/3. Now I'm going to find the tangent. The tangent of theta is the opposite, which we just said was 2 times the square root of 10 over the adjacent, which is 3. And finally, the cotangent is going to be the reciprocal, which is going to be 3 over 2 times the square root of 10. Again, I have to rationalize the denominator, multiplying by whatever's underneath the radical sign. So in this case, I'm going to multiply by the square root of 10 over the square root of 10. And when I do that, I get 3 times the square root of 10, and then 2 times 10, because that will be 10. So I'm going to have 20 as my denominator there. And those are my 6 trig functions. Boy, that's an awful lot of writing. Okay, moving on to the next one. 17 through 26, construct an appropriate triangle to complete the table. So cosine of 45 degrees. So if you wanted to think of this on your unit circle, here's 45 degrees. 45 degrees. It gives you that ordered pair of square root of 2 over 2, square root of 2 over 2. If I ask you for 45 degrees in radians, if you're looking on your unit circle, you can see that it's pi over 4. If you didn't know that for some reason, you can always take 45 and multiply it by pi over 180. Remember, here the degree symbols simplify, and I'd still end up with pi over 4. So my radians is going to be pi over 4. And then the function value. By the function value, they want the cosine. That's the function. So they want the cosine of 45 degrees. If I'm looking at this ordered pair, remember it goes cosine sine. So I want the x value. So in this case, I want the square root of 2 over 2. All that could have been gained from the unit circle. Moving on to exercises 27 through 34, they want you to complete the identity. We went over the sheet last time in class. So the sine is 1 over the cosecant of theta. The cosine is 1 over the secant of theta. The way I remember is the letters change. Like the C goes with the S goes with the C. I don't know how else to say it. Tangent is 1 over the cotangent of theta. Cosecant is a reciprocal of sine, so that's going to be 1 over the sine. Secant is 1 over the cosine. And cotangent is 1 over the tangent. And then these are actually what we call the quotient identities. So this one, a tangent is something over something, and they want the identities. So I want to see tangent is sine of theta over cosine of theta. And the cotangent is a reciprocal of that, so it's cosine of theta over sine of theta. And you are going to have to know those. So those are something that you are going to have to know. You do them enough, you know them, but if you can't, you're going to have to memorize them. I don't know how else to tell you that, but you need to know them. Hopefully this helps, and we will see you next time in class.